Hello guys, welcome to another LangChain video. In this video, we're going to be deep diving into memory in LangChain. What are the different classes that are available in LangChain to handle memory? What are the best practices as well? And also talk about, where the direction of, LangChain ecosystem is going. It is going in terms of, LangGraph, but, we have to understand everything that precedes it so that we understand properly how to handle memory in LangGraph as well. So this video will take you through everything. So first we will talk about why is memory even important, right? So yeah, people treat chat agents like they're human. So what this means is when you're talking to a human being, let's say there's a lot of to and fro happening, you expect the human to understand or remember what happened previously in the conversation so that the context is maintained, right? So that is very important. So there needs to be some way for the LLM to have memory of past conversations, right? So yeah, there have been some existing attempts to add memory to LLMs. In the past, developers have tried to add inbuilt memory to transformer models. So what this means is, it is memory is sort of built into the LLM itself, right? But so far, it hasn't been very optimal. Even the best models out there like OpenAI, Anthropic in 2025, they still don't have inbuilt memory, especially when there are better ways and more optimal ways of doing it, because having that memory in our control is very important, right? Because we can then, shape it in however way we want. So, but we can expect it to be added to models as models become more and more powerful. Okay, we can definitely expect it to, happen in the future, but right now it is not. So what are our options, right? So what options do we have right now for memory in LLMs? Firstly, put it as part of the prompt, right? So whenever you are, asking a question to the LLM, there could have been like several back and forth conversations that happened in the past. You can add all of that history to the LLM in the prompt itself, right? So that way, it will be able to answer in a much more informed way. External lookup. External lookup is basically like, using RAGs, Retrieval-Augmented Generation. If you do not know what that is, we will glance over it in the later part of the video as well. But basically you are having memory, in a database, right? Especially if the memory is like huge in amount, you put it in a database and then you keep it there. And then whenever it is required, you just like retrieve specific chunks from it and then provide context to the LLM along with the user's question. Okay, so if you don't understand it, don't worry, we will be talking more about it later on in this video. Now let us look at an example of the first one, which is put it as part of the prompt. Okay, so if you worked with LangChain before, you know that the OpenAI APIs, or Anthropic's APIs, they accept a system message and a human message, right? So the system message could be something like a digital assistant named Alex who enjoys talking with Harish, right? So this is the history of the conversation. Okay, I'm passing this history to the prompt as well, right? So you can see that I'm introducing myself and I'm telling the AI that I love photography, and the AI is like, hi Harish, I'm Alex, photography is fascinating. The user is, which is me, I'm saying mostly nature shots, especially birds. The AI saying something else. So in the future date, I can just come, continue the conversation. I can just say, hi Alex, remember my bird photography? And the assistant is like, I certainly do, Harish, right? It remembers my name as well. And the reason why it is able to do that is because we are storing the history somewhere else in our code, right? And then we are attaching that entire history to the prompt, right? All right, so this is the first one. But there are a couple of disadvantages, as you can imagine, right? So the first one is context window limitation. So what this means is, the latest OpenAI models only allow 124,000 tokens per prompt, right? So so what this means is, like, imagine the conversation is really long, right? What if the conversation is like, you talk to the AI for like, two full days and it has like, a billion tokens worth of history, right? You can't really possibly put all of that, condense it into one prompt to the LLM, right? Because the context window is going to get exhausted, right? It is going to struggle to identify, it is going to struggle to, it's going to start to hallucinate and all, and even the APIs are not going to let you dump in that much amount of history to the LLM call, right? So that is one thing, which is context window limitation. And also the latest OpenAI models only allow 124,000 tokens per prompt. So there is a limitation that is happening right here. So let's now look at, what are the ways that LangChain solves it. As you can imagine, LangChain offers a lot of classes, easy to understand classes that you can use to sort of, manage memory in a much more efficient way. So these are the simple classes that LangChain provides. The first one is conversation buffer memory, and the second one is conversation summary memory. Okay, and advanced classes we also have, like conversation buffer memory window, conversation summary buffer memory, right? So it's not just that, there are much more complicated things like entity memory and custom memory as well. So let me actually take you to the documentation of LangChain. I'll show you quickly, what are the types that are available. So if you see down here, you can see that we've got conversation buffer window, entity, conversation knowledge graph, conversation summary, token buffer, and backed by a vector store, right? Let's just jump into the code. Okay, so as you can see, I've already prepared the code for you guys. Let me just remove this. Let me zoom it in a little bit. All right. So all that I've done is, I'm using the chat OpenAI chat model, but you can definitely go for Gemini, guys. I mean, if you don't have the money, or if you don't want to pay that $5 to OpenAI, you can go for Grok, you can go for, Gemini. I've got a LangChain crash course tutorial, which I'll link somewhere up here, also in the description. There, in the very first section, I'm talking about chat models, and it's very simple to understand. You can basically, LangChain provides classes that let you, talk to pretty much any LLM out there using very simple. You just gotta swap out one chat model with another, right? So right here, I'm using chat OpenAI. Instead of that, you can just go with, Gemini's Gemini's model, or, Grok's model, or Llama's model, whatever, right? So I'm just using chat OpenAI right here. I'm specifying the model to be GPT-4o, setting the temperature to be 0, right? And the second thing is I'm importing something called a conversation chain, a conversation buffer memory. Okay, so the first type of memory that we are going to be looking at is the conversation buffer memory. If you remember, that is the first one right here. Okay, so let us understand. This is like the most basic class. If you understand this, a lot of other things become very easy. So, okay, so here's what I'm doing. I'm setting the memory to conversation buffer memory to this particular class. And then I'm also using the conversation chain right here. So basically, a conversation chain is something that, remembers, everything that happened before in the conversation, the to and fro, and then it also sort of prints it out. Okay, this is what happened. This is the history, and this is what the AI said. I'll show you in a minute. So in the conversation chain, I'm passing the LLM. I'm passing verbose true, meaning we are going to be able to see all of the logs printed in the console. Right, and we're also passing the type of memory, which is the conversation buffer memory. All right, so let's come down. All right, so this is how I'm going to pass an input to the conversation. Basically, in a real world, we are not going to be using this conversation chain, but since the focus is memory, we are going to be manually sort of adding user inputs to the conversation chain. So you can say conversation.predict and then input, hi there, I'm Harish. All right, so now entering the new conversation chain. So this is part of the conversation chain. Okay, so it says the following is a friendly conversation between a human and an AI. The AI is talkative and provides lots of specific details from its context. If the AI does not know the answer to a question, it truthfully says, I do not know. Okay, so this is part of the conversation chain. It just provides a much more easier way for us to learn memory, right? So yeah, this is how it goes. The current conversation is the human says, hi there, I'm Harish, right? So this is going to be the input that I'm providing. And let's see what the AI is going to say, right? So this is what the AI says. Hello, Harish. It is great to meet you. I'm an AI here to chat and I'll help you with any questions you might have. How is your day going so far, right? All right. So I'm going to, input my second prompt, which is how are you today? I know it's dumb, but the point is, I'm saying something else right here. And then let's see what's happening. The same thing is happening. The current conversation, it is stacking up, right? The memory is basically stacking up. So that is what is called conversation buffer. So you can see, okay, the human said this thing, the AI said this thing. Now the human is saying, how are you today? And then the AI is saying, hello, Harish, I'm just a digital entity. So I don't have any feelings in the human sense, but I'm here and ready to assist you with whatever you need, whatever you're curious about, right? So basically the first class that we're dealing with right here, this conversation buffer memory, whatever happened exactly, it is going to store it in the buffer. Okay, exactly what happened. The human said this thing, the AI said this thing. The human said this thing, the AI said this thing, and it is going to provide all of that memory to the prompt. Okay, all of that memory to the prompt. Now, it's not going to modify anything. That is the base class, which is the conversation buffer. Okay. So I can also say something else. Good. Can you help me with some content for LinkedIn? Right? I'm saying something like this, and then you can see that it is appending this new to and fro conversation to the existing history and then sending it to the LLM. Right? So the human said this thing, the AI said this thing, human AI, and then finally the human is like, good. Can you help me with some content for LinkedIn? And then the AI responds with this thing, and then finally, if I want to look at the entire buffer conversation history, I can just say conversation.memory.buffer. Okay, so buffer is where all the raw conversation history is going to be maintained. So you can see that we can see all the conversation history that happened right here. Okay, so that is what is called this particular class, which is conversation buffer. Okay, now before we move on to the next conversation summary memory, there are a couple of disadvantages when it comes to this type of memory, right? So this is very like hard-coded, straightforward, right? So every single conversation that happens, it just like appends it to the history, and every single new prompt that the human is going to provide, it is going to take all of that history, dump it all in the LLM prompt, right? So you can imagine that as time goes on, it is difficult to scale, right? The history is going to get longer and longer and longer, and there comes a point when the token limit is going to get exceeded. In that case, the LLM is not going to accept that particular prompt, or it's going to start to hallucinate, right? So this is a drawback when it comes to conversation buffer. Okay, now let's move on to the next type of this thing called conversation summary memory. Okay, so we're going to be looking at this particular thing, the conversation summary memory. All right, so let us see what this does. So even the name, the conversation summary memory, it should sort of indicate what this does, right? So it sort of addresses the disadvantage that we faced with the conversation buffer memory. Conversation buffer, it hard codes everything, whereas conversation summary memory, what it does is, instead of having all of the history hard coded in the buffer, instead of that, it is going to make an additional internal LLM call, and it is going to summarize the entire conversation. It's going to tell the LLM, okay, this is the history, summarize everything, give it to me in one string, and it is going to store it. So that way, in the future, if the user were to ask another question, then there is going to be a summarized version, right? There's going to be a summarized version, and that is what is called, that is what this conversation summary memory does. So let's see, let's look at an example, right? So I'm using this conversation summary memory. I'm again importing it from LangChain memory, and I'm passing, this time, instead of passing the buffer memory, I'm passing in the summary memory in the conversation chain. Okay, so let's see what happens. So here I'm saying, hi there, I'm Harish. Prompt after formatting the following. Okay, the same thing. The human is saying this, and the AI is saying, hello Harish, it's great to meet you. Very simple stuff, no difference so far. All right, now the second prompt, okay, can you help me with writing a funny tweet? Okay, so now let's see what happens. So instead of hard coding what I said right here, hi there, I'm Harish, instead of hard coding that, there is a summary that is created right here. Okay, so it says the current conversation, Harish introduces himself to the AI. The AI greets Harish warmly, expressing readiness to chat and assist with a variety of topics, including technology, books, right? And then the human, this is again hard coded, right? Can you help me with writing a funny tweet? Okay, so now this AI is going to answer this question very good, because it is summarized, right? It is summarized. So it is saying, of course, Harish, I'm writing a funny tweet can be a delightful way to engage with your followers. Again, I can look at the conversation buffer memory. This query right here, that would also be summarized, right? Harish introduces himself. AI greets Harish warmly, expressing readiness to chat. And then finally, Harish is asking to write him a funny tweet, right? So that is also summarized right here. Okay, so basically, instead of hard coding the entire conversation history, there is another additional LLM call that is getting made, which summarizes the entire thing. That is the only difference right here. Okay, I hope that makes sense. Let us now look at the next type of memory, which is called conversation buffer window memory. If you understand conversation, let me also show you where it is. Conversation buffer window, right? This one is what the second one is what we are talking about right now. If you understand conversation buffer, which we know that, it is just going to store the raw conversation history, right? The second one is very different. It's very similar. I mean, if you know what a window is, we can basically specify this is the amount of past conversation to and fro's that we can save in the memory. Okay, we're just saying that. So basically what this means is, instead of having the entire conversation history, instead of having the entire conversation history as we do in conversation buffer memory, instead of that, we can just instruct the LangChain class, okay, only save k is equal to 5. So in that case, only the latest 5 to and fro is going to be saved in memory. All the previous exchanges, the conversation exchanges, are going to be flushed out from memory. Okay, so that is the only difference. So let me, I hope that makes sense. Let me actually, so show you what we're doing right here. So similarly, I'm importing it from memory, the conversation buffer window memory, and then we're setting k is equal to 2, and this only retains the last 2 interactions in memory. Okay, so the same thing, I'm setting verbose to true. Instead of the summary memory, I'm passing in this window memory in the memory right here. All right, so first prompt, right? The first prompt is, hi there, I'm Harish. Okay, it is appending in the history buffer, and then the AI saying, hello Harish, I'm great to meet you. It's great to meet you. And then I'm saying, can you write me a funny LinkedIn post on something I ask, right? So what's happening right now? So you can see that, this is still maintained, right? The first human message, it is still maintained. Hello Harish, it's great to meet you, right? And then the human says, can you write me a funny tweet on something I ask? And then AI says, absolutely Harish. All right. So, everything is maintained. This particular to and fro, which constitutes as one conversation, right? That is maintained. The second one is also maintained. And then the third one is happening right now. Okay. So I'm asking a question right here. The AI is saying, of course, Harish, just let me know what is the topic. And now I'm saying memory in LangChain. I wanted to write a LinkedIn post on memory in LangChain. So now let us look at the, the history right here. And you can see that there only exists the last two to and fro conversations, right? Only the last 2 is maintained. All the things that happened previously is flushed out from memory. So you can see that, this hi there, I'm Harish, and hello Harish, all of that is like removed from this particular history right here, right? So this would particularly be helpful if, there are applications where, most of the cases only the last 2 or 5 or at max 10 history exchanges are required. Everything else we can probably remove, right? The users aren't going to be able to notice it. So in that case, we can go for this particular type of this thing called conversation buffer window. Okay, so that is why we have this window. We can specify the window. It could be k is equal to 3, 5, 10, whatever. Okay. All right. So let us now look at the next type of memory class, which is called conversation summary buffer memory. Okay, so you can find it right here, conversation summary buffer memory. So this is a hybrid model. Okay, so in the past we've seen the window memory. Basically, you can specify k is equal to 2, and it is only going to retain the last 2 conversations, and then everything else is flushed out. We also know the summary memory, which is going to summarize everything that happened instead of keeping the hard data, the raw data. This is a hybrid wherein we can specify, okay, these are the amount of conversations that we have to hard code, and then whatever is before that, don't discard it, but rather create a summary of it. So there is another LLM call that is being made, and that summarizes everything together. All right. So that is what this does. So if so there's a small difference with this particular class and the window memory. In the window memory, we specify a k value. K is equal to 2, k is equal to 3, k is equal to 5. But this one, we are specifying the token limit, right? So right here, I'm specifying the token limit to be 40. Okay. So let's look at this particular conversation chain. Here I'm saying, hi there, I'm Harish. And all right, so this history is maintained right here, and the AI gives a response. And then you can see that I'm asking another question right here. I'm asking the AI to, write me a LinkedIn post. And then let's look at the history right here. Okay, so the history, all the human AI messages, it is summarized right here. Harish introduces himself to the AI, right? And the reason why it is not, restoring the original thing despite me setting 40 token limit, that is because even that particular thing, exceeded the 40 token limit. So let me actually try to, increase it to, let's say 200, right? So let's try to do that. I'm increasing it to 200. All right. So I've just increased the token limit to 200 and I'm running it again. So right now you can see that, humans is this thing. As usual, we've already seen this. AI responds with this particular thing. And then this is the second input that I'm providing, which is I'm doing good. Can you write me a LinkedIn post? So now because I've increased the token limit to 200, you can see that this first thing is maintained right here. Okay, previously because I set it very less, it started summarizing it right away. But then since I set it to 200 right now, it is maintaining this. Hi there, I'm Harish. Hello Harish, it's great to meet you. And this is the next input that I'm giving. Can you write me something about AI agents? Keep it short, right? So yeah, ever since after that, it has started to summarize everything. And that is how the conversation summary buffer memory works. So far we've seen how the conversation buffer memory works, how the conversation summary memory works, and also the hybrid types like conversation buffer window memory, conversation summary buffer memory, right? So let's now go ahead and start looking at what is entity memory. So let us now look at what is entity memory. So this type of memory remembers information about different entities. So first, let's look at what is an entity. Let's try to understand it better so that we'll be able to see exactly what is this problem that entity memory solves. So an entity is any specific person or an organization or a product or concept that we want to track information about. Okay, so entity memory stores and updates information about these entities across conversations. The LLM refers back to the entities and their values for future user prompts. Okay, so I'll give you some examples of entities as well. A person entity could be John, right? John is an entity, right? John is a software engineer who likes coffee, right? So the LLM is basically going to create entities like, John equals software engineer who likes coffee, right? So the difference between all the different types of memory classes and this is that instead of summarizing it or hard coding everything together or something like that, instead of all of that, it is just going to have a dictionary or an object of entities, and it's just going to have John, and then this is what John does. If there is another entity that comes in, let's say Google introduced a particular product, let's say Google equals introduced a particular product. Product entity, iPhone 14 is a smartphone released in 2022. Company entity, so Tesla is an entity right there, right? Tesla equals makes electric cars and batteries, right? So let's look at an example that I've prepared. This is basically to sort of help you contrast between, without using entity memory and with using entity memory. All right. So this is the without case, and we are not using any type of memory for that matter here, right? So I'm saying, me, the user, is saying my cat Whiskers is 3 years old. The AI is like, that's nice. And then you are saying Whiskers likes tuna. The AI is saying, oh, you have a cat. What was the name again, right? Because there is no memory at all. So the LLM does not know, what has happened before, right? Let's look at, with entity memory, what happens. So with entity memory, if I were to say the same thing, my cat Whiskers is 3 years old, the entity memory gets saved. Whiskers is equal to cat age 3. AI is like, that's nice, and then you are saying Whiskers likes tuna. And then the entity memory gets updated as time goes on. So Whiskers is now equal to cat age 3 likes tuna. And the AI now has access to that particular entity, and then it is saying, oh, good to know what Whiskers enjoys. Does your 3-year-old cat like other seafood too? And then I'm saying, does Whiskers like, in the future, if I were to ask something like, does Whiskers like fish? Well, since Whiskers enjoys tuna, they probably like other fish too. So you can see that the AI now has access to this entity memory, right? So this object of, entities and their values are available to the LLM. So instead of storing the hard raw data in the memory, or instead of, summarizing everything, this is like, creating entities so that it becomes very easy for the LLM to, draw relationships between different entities. Okay, so let's look at the advantages of using this particular entity memory, and you'll be able to see where you can sort of employ this particular type of memory in your applications. So more efficient storage, right? Only keeping what matters, right? Better organized information structured by entity. In the past memory classes, this would not be possible, right? Easier to update and reference specific details as well. Less context window usage since you're not storing every single message. All right. So this is all for entity memory. Let us now move on to another type of memory. There's another type of memory after that, but the last but before one is going to be the conversation knowledge graph memory. This builds on top of the entity memory that we saw earlier. Let us look at what this does. So this conversation graph memory is what we have right here. All right. So think of CKG, or basically short for conversation knowledge graph memory, as a sophisticated way to connect information in conversations, like creating a web of relationships between different pieces of information. So let's look at an example. Without a knowledge graph, what happens? So I can say John works at Apple. Apple makes iPhones. Who makes John's company's products, right? So AI might struggle to connect these facts, right? So basically imagine that this is pretty straightforward. You might argue that the LLM can figure these things out, but imagine there is like so many different relationships that are happening in the past. The LLM might actually struggle to or there's a lot of noise. Basically it is not a clear signal for the AI to go and fetch the relationships, right? So let's look at with knowledge graph. So you are saying John works at Apple. So basically what the LLM does, it creates nodes and relationships. So it says John works at Apple, right? And then again I'm saying Apple makes iPhones. It adds relationships. Apple makes iPhones. And then again, if I were to ask a question, let's say who makes John's company's products, it can follow the connections. John, Apple, iPhones. So the AI can easily answer the company John works at Apple makes iPhones. Okay, so entities is basically I'll give you exactly what are the differences between what are the key differences between conversational knowledge graph memory and entity memory. So instead of just storing facts like entity memory, it stores the knowledge graph memory, it stores a relationship between those facts. Okay, so that is the only difference. Information is stored as a network, not just a list, right? So you can imagine a graph to be a network of things, right? But if we were to look at the entity memory, it is just a list of things, right? So can answer complex questions by following these connections. So think of it like entity memory is like keeping organized notes about individual things, whereas a knowledge graph memory is like drawing lines between these nodes, not nodes, nodes, to show how everything is connected together. Okay, so now you might have a question. Can't LLM figure out the relationship on its own? We can just use a conversational buffer memory for everything, right? That seems like a very simple thing, or conversation window buffer memory, right? Or a summary memory. So why not? Why do we have to, in some cases, go for knowledge graph memory? So one thing, the obvious thing is context window limitations. The conversation buffer memory, here's 1,000 message conversation about, John, Apple, iPhones, and other topics. The LLM has to process all of this to find the relevant connections. Okay, but in a knowledge graph, there is a graph-like structure and all the relationships are maintained. All the relationships are maintained. So John works at Apple, makes iPhones. So it gets straight to the point with relationships. Okay, let's look at the second one, reliability of extraction. So let's contrast conversation buffer memory and knowledge graph. Okay, so the human, if the human says who makes the products at John's company, AI has to scan through potentially hundreds of messages, might miss connections if they're far apart, could get distracted by irrelevant conversations in between because there's so much noise, right? But in a knowledge graph, human says, okay, who makes the product at John's company? AI follows a clear path. John works at Apple, makes products. So it is a structured path. The LLM doesn't have to work as much. You save context limits, you save a lot of money there as well, but at the same time you get more reliable answers. All right, let's look at the third one, noise versus signal. So the conversation buffer memory might contain, the entire history, right? Hi, how are you? Good, thanks. By the way, John works at Apple. That's cool. Did you watch a game yesterday? Apple makes iPhones. These are some history that, it is stay saved. But knowledge graph only extracts all the relationships between each of those things. All right. So the summary is that even though LLMs are great at understanding relationships, giving them structured data, knowledge graph, instead of a raw conversation buffer helps them be more, precise, efficient, reliable, and memory efficient as well. All right. Now, so we've come to the last type of memory that LangChain provides, which is called vector store backed memory, right? So I'm hoping that you already know what vector stores are, retrieval augmented generation is. If you do not know it, I've got a LangChain complete crash course where I'm teaching everything from scratch about what RAGs are, what vector embeddings are, what vector databases are. But if you do not know it, that is completely fine. I will give you sort of like a primer on it. Okay. So let's look at what are vector embeddings first. All right. So words and concepts are converted into numbers that capture their meaning. All right. So that is what a vector embedding is. We're converting all the words, sentences, everything into a numerical representation so that, for example, cat and kitten would have very similar number patterns because they are related. All right. So basically, what is a vector storage or a vector database? A specialized database that stores these vector embeddings. All right. So it can quickly find similar patterns when you search for something. So we are able to semantically search for, the right parts from the database based on whatever the user is asking for, because everything is converted into a numerical representation, like having a smart filing system that understands meaning, not just exact matches. All right. So why use vector storage? It can handle massive amounts of text efficiently, finds relevant information even if you use different words, much faster than searching through raw text. Perfect for finding, perfect for searching through years of meeting recordings, documents, or chat logs, right? So you can imagine that, basically, let's say you want to store, all the information, all the content. Let's say you want to, record or transcribe all of these Zoom meetings that happened in your company for the last 1 year. And you might have had like so many different meetings every single day, right? That is a lot of data. And you want the AI to go and search for, okay, what happened on this particular day at this particular thing? What did we talk about with, let's say, John, right? So if you want the AI to go and retrieve that particular thing alone, you can't like dump all the text to the LLM prompt. It's not going to work out, right? Because the context limit is like, it's nowhere there, right? So that is exactly why we store it in this thing called vector database, and then we can query it, and that serves as a memory for us, right? So this is the last type, which is the vector store backed memory. So basically we're using a database here and not a class or anything like that, a LangChain class. So far we've looked at all these different types of memories, but you might also notice another thing. If you come to this LangChain documentation, if I scroll up right here, you can see that, this is a documentation for LangChain version 1, which is no longer maintained, right? You have to go for the latest version right here. So the latest version recommends that we use LangGraph to maintain memory and not these particular classes. And the reason why I still included that in this particular video is that, we still have to understand all these different types of, memory in order to efficiently use it in LangGraph. So LangGraph, the way it handles it is a little different. That is a separate course on its own, but I will give you a very short primer as to how LangGraph handles it. All right. So I've prepared the code for that already. So let me come right here. So basically, when we're working with LangChain, you can imagine it like chains, right? It goes from left to right, right? It goes from, the starting, it goes from the next thing. You can't really stop it. You can't really have a human come and review it. It starts from the start and then goes till the end, and nothing can stop it. So that is a chain. There is no real intelligence involved. Whereas with LangGraph though, there is a lot of, flexibility in how we can actually do things. So we can actually pause a particular node executing, make it wait for a human to come and approve it. You can have a human in loop scenarios done. You can create really complex agents, which is not possible with LangChain, right? So these are some things that LangGraph does, which is why the entire world is sort of moving towards LangGraph for creating complex agents. But As far as memory is concerned, it is pretty straightforward. So if you do not know how LangGraph works, you can basically think of it as a graph data structure. Okay, so in a graph data structure, we have multiple nodes and all these nodes have relationships with each other. That is how LangGraph does as well. And it gives you a lot of flexibility of building really powerful, agents, right? Agentic workflows, right? So this is the code. This is where we are actually initializing the app. Let's actually go to this create chat app. Okay, so this is a very simple chat application, the chat bot that we're building right here. So first off, we are defining a new graph. I'm saying state graph, and then we are passing the messages state right here. Okay, so the way it works is there is a global, you can think of it like Redux for applications, but instead for the entire node data structure, there is going to be one central store for saving the state, right? So that is going to be this particular messages state right here. And then, we are defining the model here as well. Basically every LangGraph app to have a start node and then an end node, right? So this is going to be the start node. We are adding another node right here called the call model node, where anytime this particular node is called, it is going to invoke the LLM and then it is going to store the latest message to the messages list that we saw right here. You can think of it as like an array of messages, and every time we call this particular call model, it is going to take the latest response and then append it to the global store, the state. And then if we come down here, we have memory saver, right? And this is going to be the memory saver class, and we are providing the memory right here. Okay, so in the workflow compile, we are providing this is the type of memory. We are instructing LangGraph to use this particular type of memory, and then we're starting to run this particular thing, right? So I'm getting the user input, and then if I were to say quit, it just comes out of the loop, or else it just loops through the same thing again and again and again. And then this memory saver is going to basically, what this memory saver is, it's the exact same thing as what we saw in the conversation buffer memory. It just saves everything as a raw data, right? So if I were to run this thing, so I can say something like, hey, my name is Harish. Okay, hello Harish, it's nice to meet you. Okay, and now I can say what is my name, and it is going to say your name is Harish, right? So basically how this works is no different to this particular conversation buffer memory. Okay, so this is how LangGraph does it. Learning LangGraph is like a separate tutorial altogether, but I'll just give you a primer on how LangGraph handles memory, right? So right now we are using this class called memory saver, which is going to be, as I said, the equivalent of the first class that we saw in LangChain. If we want in the future to have a buffer window, there is going to be another class corresponding to the same thing, right? Similar to that, we have entity memory as well. Similar to that, we have conversation summary as well, right? So now that we understand all these different types, picking this up is going to be very, very easy. So if you're interested in LangGraph, I've got a complete crash course on LangGraph, including memory, that I'm attaching right here. Depending on when you're watching, it might be there or not, but I'll be attaching it right here. But if it is not there right now, do subscribe to the channel so that, when I do put it out, you'll be the first to know. So that's pretty much it on memories in LangChain. I'll see you in the next video.